what we've done so far is we've looked at linear sequences, and what we're going to do next is we're going to look at quadratic sequences. So with sequence and series or patterns, whichever way you want to view it, what we've looked at so far is linear sequences or arithmetic sequences, and what we're going to look at next is quadratic sequences. Now, the important thing to know at the minute is what we have come up with. So, linear sequences. What we found from linear sequences is that the first difference is constant. And what we mean by that is that we've got the same, so let's just say we had 4, 7, 10, 13, and so on. The first difference was plus 3, plus 3, and plus 3. So we know that the first difference in each of them there was constant. So now we're going to look at quadratic sequences. And you can see there, the quadratic sequence is this one here. And they're slightly different. So what you'll notice about a quadratic sequence is that the first difference isn't constant. So let's look at the first difference there. Plus 3, plus 5, plus 7, plus 9, and plus 25 plus 11. So you can see here, if we have a linear sequence, the first difference is always constant. That's important. Okay. In a quadratic sequence, the first difference is a constant, but you might notice there that the second difference is constant. So you can see there that from here to here, the second difference is constant. So in a quadratic sequence, the second difference is constant. And we'll just call that the second difference. So the second difference is constant. So that's the main thing. That's the difference between the two. So if you have a linear sequence, the first difference is constant. If you have a quadratic sequence, the second difference is constant. Okay? So it's always just a matter of getting the differences. If the first difference isn't the same, and we can see there it's not the same, then go on and find the second difference. Okay? And that's, we know, the difference between a linear sequence and a quadratic sequence. Just to be sure, so people are aware, linear just means straight line. So a linear represents a straight line. And the reason why it's a linear sequence is because it's increasing by the same amount each time. So think of it in terms of a slope. It's increasing by the same amount each time. Quadratic sequences are U-shaped or N-shaped. And we looked at a full chapter there on quadratics going back, factorizing quadratics and so on. But you'll see quadratics in a small bit, and quadratics are all to do with x squares, aren't they? So quadratics are all to do with x squares. When we look at x squares there, this is the most basic form. So if you think of it in terms of x squared, let's say we took x squared as t of n equals x squared. T of 1 would give us 1 squared, which is 1. T of 2 would give us 2 squared, and 2 squared would give us 2 squared would give us 4, wouldn't it? Okay. So if I put 3 in, 3 squared will give us 9. 4 squared will give us 16. 5 squared will give us 25. 6 squared will give us 36. So you can see there how that's a quadratic sequence. Okay. We're now going to look at question 2. So again, we're back looking at quadratic sequences, and we're going to do question 2 here, right? So find the next 2 terms in these quadratic sequences by finding the first and second difference. Now, the key thing to see here is that they're asking us to find the next 2 terms, and they're telling us that it's a quadratic sequence, but we would have worked that out as we did the question. So let's have a look and see. So, with the first one, 3, 4, 6, 9, and 13. Anytime we get a sequence, we want to know what the next term is. And it's like everything that we do in maths. If we want to know what the next term is going to be, we need to be able to see what happened before. So how do we link this into this? Okay, so how we find that is we get the first difference first, and that's find the difference between the terms. So to go from 3 to 4, we added 1. To go from 4 to 6, we added 2. To go from 6 to 9, we added 3. And to go from 9 to 13, we added 4. This is what we call the first difference. Okay, so it's the difference between the terms. The second difference is the difference between the first difference. So we can see here, to go from 1 to 2, we added 1. To go from 2 to 3, we added 1. To go from 3 to 4, we added 1. So you can see there that the second difference is constant. So the second difference is plus 1. So we can see how that pattern is developing. So we want to get the next 2 terms here. So in order to get the next 2 terms, we obviously need to work from here. Okay, so let's just put in the next 2 terms, and I'll do them in blue just to see how we're developing that. So we're going to add 1 here. So if we start at 4 and we add 1, we're going to be adding 5. So we're going to have plus 5 here. If we had 13 and we add 5 to get our next term, then our next term there is going to be 13 plus 5, and 13 plus 5 gives you an answer of 18. Okay, so that's the first term, 18. We now need to find the next term. So far we've got first 1, 2, 3, 4, 5, 6. We have the first 6 terms. We're now going to see what the 7th term is. And how we find the 7th term is we follow the same pattern. So we had plus 1, so we're going to add 1 to this one. We were on plus 5, but if we add 1, we'll get plus 6. And if we look at 18 and we add 6 to it, 18 plus 6 will give us 24. Okay, so that's part 1 done there, and you can see there that we found the next 2 terms. So the answer there is 18 and 24. I'll give you guys a second there to try part 2. You should be able to try that by yourselves or be able to correct what you've done, see if it's correct. So 3, 6, 11, 18, and 27. I'll fill in the first term, or the first difference even. To go from 3 to 6 is plus 3. To go from 6 to 11 is plus 5. To go from 11 to 18 is plus 7. And to go from 18 to 27 is plus 9. And we can see the second difference there is going to be plus 2. So to go from here to here is plus 2. To go from here to here is plus 2. To go from here to here is plus 2. So we can see there the second difference is constant. If the second difference is constant, it means we have a quadratic sequence. Okay, so we know it's quadratic. We need to see how that quadratic sequence is going to develop. So if we were to find the next term, in order to find the next term, we need to find how much it's going to increase by. So 27 is going to increase by a certain amount, and that amount is going to be based on what we add to it. So we have to find out what we're adding to it. So if we add 2, 9 plus 2 is 11, and 27 plus 11 is 38. We're going to add 2 to that one. So if we add 2 to 11, we'll get plus 13. And 38 plus 13 will give us 51. Let me just double check that I'm right there. 1 and 51, that's correct, okay? So you can see there the next two terms to this sequence are going to be 38 and 51. Okay, that brings us on to the last part there, which is part 3. And we'll have a look at that now. So part 3, we've got a sequence 2, 7, 14, 23, 34. And it goes on and on and on. We need to find the next two terms. So in order to find the next two terms, we need to develop an understanding of how this was generated. And how we do that is we look at the difference between the terms. So here I added 5. Here I added 7. Here I added 9. And here I added 11. Okay? So that's my first difference. I now need to look at the second difference. So I'm trying to develop an understanding of how this is going to generate. Now, some of you straight away would look at that and you'll say, obviously, I'm going to have to add 13, I'm going to have to add 15. Some of you will spot that straight away because you can see the development there. But it's always good practice to fill in your second difference. So the second difference is plus 2, and plus 2. So that brings us to our next term, which is going to be plus 2. So like I said, this will be plus 13. And 34 plus 13 is going to give us 47. Okay, that's the first term. I now need to find the next term. So I'm going to apply the same rules. You can see here that the rule is very, very simple. It's just plus 2. And that rule, that's very, very simple, causes all of these to increase. So instead of adding 13, I'm now going to add 15. So plus 15. And if I'm going to add 15, this term here is going to go from 47 to plus 15. So 47 plus 15. So if I add the tens, I get 57. 57 plus 5 will give us 62. So that will give me 62. Okay, so you can see there the next two terms are going to be 47 and 62. Question 3, right? So question 3 asks us whether or not these are quadratic sequences. So I want us to look at these sequences and say, are these sequences quadratic, right? Now, these sequences, what we know is in order for them to be quadratic, they have to follow the very simple structure that we have, and that is that the second difference has to be constant. So let's take each of them. We'll take the first one there. 6, let's number this, 6, 8, 12, 18, 26, and 36. So I want to test to see if it's quadratic. And if I'm testing to see if it's quadratic, it means the second difference has to be constant. So let's have a look. Here I've got plus 2, plus 4, plus 6, plus 8, and obviously that is going to be plus 10. And I can see the second difference here is going to be plus 2, plus 2, plus 2, and plus 2. So I know that this one here is quadratic. So the first one there is quadratic. So the reason why this one's quadratic is because the second difference is constant. So part 2. Part 2, the sequence for part 2 was 6, 8, 10, 12, 14, and 16. Now, I need to look at that. I want to find out, is this quadratic? So to find out if this is quadratic, if it's quadratic, the second difference will be constant. So I'm going to have to find out what the second difference is. So we'll start off by getting the first difference. Plus 2, plus 2, plus 2, plus 2, and plus 2. Now, the only thing I'll notice here is that the first difference is constant. So what I know already from doing patterns and sequence and series, what I know from that is that this one here is going to form a linear sequence. And the reason why this is linear is because the first difference is constant. So if it's linear, it's not quadratic. It's either going to be linear or quadratic. So in this case, it's going to be linear. That brings us on to part 3, right? So part 3. I'll do part 3 here. So part 3, and we're just going to squeeze that in there. So we've got 3, 4, 7, 12, 19, and 28. 3, 4, 7, 12, 19, and 28. So we're testing to see if this pattern is quadratic. So to see if it is quadratic, we'll have to get the first difference. Plus 5, plus 7, and plus 9. So that's our first difference got, okay? Because the difference between each of these is 1, between this is 3, between this is 5, between this is 7, and between this is 9. To get the second difference, which I'm going to get now, it's going to be plus 2. So is this linear or quadratic? In this case, the second difference is constant. So if the second difference is constant, it is quadratic. Okay. We get on there and do the last part, the last question. So the last question there is part IV. And we've got 0, 3, 8, 15, and 24. So again, I'm trying to see if this is linear or quadratic or what it is. So in order to find that, what I need to do is I need to see how the pattern is developing. So here I'm adding 3, adding 5, adding 7, and adding 9. That's my first difference. You can see there the first difference is seems to be increasing by 2, but let's just make sure of that. So if I 3 to 5 means add 2, 5 to 7 just means plus 2, 7 to 9 just means plus 2. So you can see there that this pattern is developing based on the second difference, and the second difference is constant in this case, so this one is also going to be quadratic. So the most important thing to take from this question is that in a quadratic sequence, the second difference is always constant. And on a side note from that, you can say in a linear sequence, which you should already know, in a linear sequence, the first difference is constant. Okay. So we'll skip on there and we'll do question 4. So with question 4, it says t of n is equal to n squared plus 2n minus 4. Work out the 10th term. So everyone should be able to do this based on what we were doing with linear patterns. It's the exact same as what we do with linear patterns. N represents the number of the term. So if I wanted to work out what the 10th term was, I'd have to put 10 in for n. So t of 10 will be equal to 10 to be squared plus 2 times 10 minus 4. So that gives us 100 plus 20 minus 4, which gives us 120 minus 4, which gives us 116. So you can see there, they want to know what the 10th term is going to be equal to. And I've worked out there that if I put 10 in for the number of the term, I get a 10th term of 116. Okay, so the 10th term there will be 116. We'll skip on there to question 6. So with question 6, it says write down the sequence as follows. They want us to find the first difference, they want us to find the second difference, and then they want us to find t of n is equal to an squared plus bn plus c. Use the second difference to write down the value of a. Okay, and I'm going to show you that now, right? So we'll start off by writing out the pattern. So 4, 7, 12, 19, and 28. We're going to get the first difference by adding 3 here. What did I do with 7 turn into 12? I added 5. What did I do with 12 turn into 19? I added 7. And if you're unsure, all you're doing is just taking 19 take away 12. And what did I do to 19 turn into 28? I added 9. And again, all you're doing is 28 take away 19 leaves you with 9. So you can see there we got the first difference like they've asked. We now need to get the second difference, and the second difference in this case is plus 2, and plus 2. So we can see there the second difference is constant, and the second difference is plus 2. So I've done the first difference like they've asked. I've done the second difference like they've asked. They now want me to form t of n, right? Now, they haven't asked me to form the full equation. They've just asked me to find the value of a. And what you're going to learn from this is the value of a. So when you have a quadratic equation, okay, or a quadratic pattern like this, the value of a is always half the second difference. So you take the second difference and you divide it by 2. So the value for a, so you might want to take a note of that. Okay, so t of n is equal to an squared plus bn plus c. And the note that you'll be taking is that a is always half the second difference. So in this case, the value for a, my answer there for a will be equal to 1, because half of 2 is 1. So the second difference there is 2. Half of 2 gives me 1. So my value for a there is going to be 1. And we'll come on to more questions based on that, and we'll come on to questions that ask us to form the quadratic equation, and we'll be coming on to that next. But the main thing to learn from today's lesson is that when you're forming a quadratic equation, the a, or the term that comes in front of the n squared or the x squared, whatever we want to call it, is always half the second difference. So half the second difference.